Hi guys, today I will be telling you all about the Tripoli Breakwater. The Breakwater is located in the capital of Libya, protecting the port of Tripoli. The port is situated on the southern coast of the Mediterranean Sea, with its breakwater extending over 4,000 meters. The port of Tripoli is actually one of the oldest harbors in North Africa and was a common trade route. Breakwaters have existed at the site for a really long time, with the original ones dating all the way back to the Spaniards. So while it might not have been called a breakwater and the designers might not have been called coastal engineers, they still understood the damage that wave energy can have and knew they needed to protect the harbor. In the mid to late 1900s, Libya experienced an increase in oil-based economic resources and were in need of an expansion of their port facilities. So, in the 1960s, some guys by the name of Sir Bruce White and Wolfe Berry designed a new and improved rubble mound breakwater. This breakwater was set to be built in two stages. Stage 1B was constructed from 1972 to 1976 and was about 2,200 meters long. Stage 2A was constructed from 1974 to 1980 and was about 2,500 meters long. The site conditions for this design were based on the available and known wave data at that time. So a significant wave height of 4 to 4.5 meters were used, a maximum depth of 12 meters, and a fetch of over 1,000 kilometers. The structure had 3 layers of armor of varying sizes, with the outermost layer being 18-ton tetrapods. The berm was constructed with 5 to 8-ton rock, and there was a concrete wave wall that sat about 9 meters above the mean water level. I want to note that the image being shown here is actually depicting the breakwater from stage 1B, and we know this because of the long backfill of sand on the right side. This was done to create a reclaimed area for the harbor that would house a double carriage roadway, storage areas, and sheds. So the design for 2A was almost identical, minus the backfill. And so how did this design hold up? Well, it failed, and it failed a lot. Aside from the issues that they had during construction, like overtopping and venting that caused sinkholes and a whole other mess of damage, the original design was vastly under-designed. In 1981, there were 2 major storms that hit the port with significant wave heights of 10 meters and peak periods of 14 to 15 seconds. Remember how they only designed for a significant wave height of 4 meters? Well, that became a problem and caused massive damage to this breakwater. The vertical wave wall collapsed along large sections, leaving those sections vulnerable to overtopping. Tetrapods were displaced and broken. Venting through the permeable layer caused the core to blow out and damage the reclaim area. More overtopping led to erosion of the structures on top and completely wiped out the roads. And finally, the berm was damaged by erosion from the waves. But don't worry, the super experienced coastal engineers from the Netherlands came to the rescue to redesign the structure in 1982. They redesigned based off of the 100-year return period storm, which accounted for a significant wave height of 10 meters and a peak period of 14 to 15 seconds. Their critical design factor at this point was overtopping, since it was causing massive erosion to the reclaimed area. Essentially, no overtopping was going to be allowed in their design. The new design called for an extended berm to reduce wave pressures on the wave wall, an increased weight for the wave wall, nearly double what it originally was, a 3rd layer of 18-ton tetrapods to reduce overtopping and increase stability, and finally, a large barrier mass behind the wave wall to prevent venting. So this design looked like it might actually work, but in a devastating turn of events, it was never built. As far as I can tell, the structure just kind of sat there for years, receiving more and more damage. Finally, in 2009, a reconstruction project was undertaken by the Libyan Maritime and Ports Authority, and this new design called for an extended berm, additional armor made of rock and precast concrete, new primary armor layers, and an open canal filled with rock behind the existing parapet structure. There's not much news about the current state of the design, so we can only hope that it's holding up and doing well.